All right, here we are for acceleration questions and problems, set 1. We are on the final problem, the final calculation on that set. They give you this graph, and they say, hey, it's a position versus time graph. They say, during what time periods, if any, is the object's velocity constant? Well, how do you find velocity on a position time graph? Velocity, you remember, its definition, it is the rate at which you are changing your position, right? It's the rate of change of position. And you say, well, how quickly this position is changing as time goes by. That has to do with how steep this line is. So if I want to know when the velocity is constant, that's when the steepness is constant. That's when the line is a constant slope. That means it's a straight line. I believe this is intended to be straight here between 0 and, what should we call that? What do you think? Want to call that, looks like each box is 5. Want to call that 17.5 seconds? Sure. So I would say from t equals 0 to 17.5 seconds. Okay. At what time is its velocity the greatest? Well, velocity is the rate of change, how quickly you're changing your position. And so again, that's the slope, the steepness of the graph. So where the velocity is the greatest, that's when this is the steepest, right? And you say, well, this is pretty straight right here, right? You see it getting steeper, 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 right? As I'm trying to do this, draw this in tangent to this curve to find the slope. And then it gets shallower, 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 right? Right now it's a 0 slope, and now it gets bigger, 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 negative. So depends on how picky we are. Are we going to worry about the sign on the velocity, whether it's positive or negative? Are we going to say that it's greatest when it's a positive value is bigger than a negative? I don't think so. When I deal with velocity, the sign is just for direction, and generally the greatest velocity, I would say a negative 10 meters per second. I would say, hey, that's changing velocity faster. Or changing position faster. Sorry, let me rephrase that. Velocity of 10 meters or negative 10 meters per second. It means every second we go in the negative direction 10 meters. That's pretty fast. I would say that's a bigger velocity than a positive 2 meters each second. Changing position by 2 meters each second. Changing meters by 10 meters a second. The negative or positive direction doesn't really signify for just how big that magnitude of velocity is. So I would say just pretty much it's just going to be when this line is the steepest. So do you think it's steeper here at the start of this curve, or do you think it's steeper here before it kind of starts to bottom out there? So, or do you think it's like a mirror image sort of thing? I don't think so. This looks like it kind of flattens out all here pretty quick. I suspect that the steepest part of the graph is right in here. I really think this is probably where it is the steepest. And so that would be when the velocity be greatest, right? And so I'm going to say that it looks to me like it's probably steepest maybe right around here, okay? So maybe right around 25, 27 and a half or so seconds in, 20, 25, 27 and a half, so around 27. Okay, and that's when a tangent line, a line that just touches the curve at one point, would be the very steepest there. I believe that's going to be steeper than anywhere on here even. All right, at what time, if any, is the velocity 0? You say, well, to have a velocity of 0, what does that look like on a position time graph? Well, velocity is the steepness, it's the slope. A 0 velocity would be a 0 steepness. It would be a slope of 0. Slopes of 0, they look like horizontal lines because slope is rise or run. I'd be changing position, no change in position per second. That'd be like a horizontal line, staying in a position. Do I have a spot here where it's horizontal? Well, not for any like length of time, but isn't it true that just like if I try drawing a tangent line, various places I can draw tangents, you say, but if I drew a tangent in here, wouldn't that tangent line look a lot like this? It'd be a horizontal line that just touches the curve at that one spot. So we call a tangent line. And the slope of the tangent is the slope of the graph at that point where it touches the point of tangency. And so I can say here that right at this time here, 37 and a half. So it looks like at 37 and a half seconds. Okay, is a spot where the velocity is 0. Now, it's not 0 for like very long at all, right? For almost no length of time. It just kind of passes through that speed. Okay, part D. What does the object run in one direction or in both during this time shown? Now, by run in one direction, it's talking about moving. We're thinking about velocities. And how do we indicate the direction of a velocity? Well, by the sign. If I'm going to go in both directions, I would have to have a part where I have a positive velocity and then a part where I have a negative velocity. And you say, well, let's see, velocity on a position time graph, the velocity is the steepness. So if I'm changing direction, I've got to go perhaps from positive slopes, so positive velocities, to negative slopes or negative velocities, or vice versa. So yeah, if you look at this, these slopes here, they're all going up. The graph is, I'm adding to my position each second. These are positive slopes until I get to this point. Now my slopes are all negative. So, so we say it's not going in one direction, it's going in both. Okay, it's going in a positive direction from time 0 to 37 and a half, and then from 37 and a half on to the end, we are going in the negative direction. All right, that's it, because we got positive slopes and negative slopes, so we are changing directions, and it happens right there is where we change directions when the slope is 0. All right, that wraps up that problem set.